This is first experiment. What is the name of this experiment? Current series feedback amplifier. Current series feedback. It is positive type or negative type? Negative. This is a sub part of negative feedback. Right? What is there in the circuit? This is simple single stage common emitter amplifier. Here if you check, these two connections we are using for VCC. This you are using for input and this you are using for output. Now 4 resistors are connected here. What is the function of these 2 resistors? They are acting as voltage divider biasing. All of you know that for what biasing is used. In the first semester we studied biasing is used to operate the transistor in active region, because here we are using this transistor for amplifier. When it is used as an amplifier device, the operation of the transistor should be in active region. So to keep the transistor in active region, who is responsible in the circuit? Resistor R1 and R2, which is also called as self-bias circuit. Not only voltage divider, but the same name, once again I can say self-bias. What is the function of this RC? RC is used as a current limiting resistor for collector terminal. Sometimes this is also called as load resistance, right? So whatever current is flowing through the collector terminal of the transistor, that current is controlled with the help of RC. Most important, what is the function of RE? Last time we studied, RE is used as a feedback resistor. Whatever feedback is there in the circuit, who provides that? RE resistor. So when this C is connected or disconnected, that will decide whether it is with feedback or without feedback. In that, when C is connected like this, means C is present in the circuit. When C is present in the circuit, circuit works as without feedback. If I remove this connection, now C is not there in the circuit. When C is not there, circuit works as with feedback. As we studied, when feedback is not there, at that time the gain of the circuitry will be high. But when I connect feedback signal, the gain of the circuit is reduced. Why? Because negative feedback reduces the gain. That is the only disadvantage of the circuit when we are using negative feedback signal. As compared to gain, if you check all other points, what are that? Maybe stability, bandwidth, distortion, noise, input resistor, output resistance. Related to all these properties, if you check for negative feedback, all these properties are considered as an advantage. But here, except gain, which is reduced, only disadvantage in the circuit. So here, this capacitor is used as a blocking capacitor. What it blocks? By chance, if any DC signal is present in the AC, that is blocked by this capacitor. For what this capacitor is used? This is also used to block DC. But this capacitor blocks which DC? Connected as a VCC. Whatever VCC is connected here, that VCC should not be available at the output. So this VCC is blocked by which capacitor? This capacitor. This one is called as CB and this is called as CC, because it couples the output of circuitry to the load. What is the function of this capacitor? First, this is called as bypass capacitor. Whatever RE resistor is present here, that RE resistor current is bypassed when this C is present in the circuit. Whatever AC signal we are getting here, that AC should not drop across RE. If it is dropped, the magnitude will decrease. If you want to avoid that, we should connect this bypass capacitor. But here, this capacitor gives you the idea about with feedback or without feedback. Once again I repeat, when this is connected, circuit acts as without feedback, and when it is disconnected, circuit acts as a with feedback. So here when you will complete both observation table, you will find out that with feedback gain is always less than without feedback, because negative feedback decreases the gain. So after completing this experiment, what conclusion you will take? Whenever feedback signal is present, the overall gain of the circuitry is reduced. Though the gain is reduced, except gain property, all other properties of the circuitries are advantageous whenever we are going for negative feedback. So that part we are studying in this first experiment. Right? So once again I repeat, these two connections are for power supply. The DC power which is coming from this power supply, that you will connect here. These two are used as a input terminal. Whatever signal generator output is there, that output you are connecting to these two input terminals. Whatever sine waveform we are setting here, whose value is 20 millivolt, that 20 millivolt signal I am connecting between these two terminals. And after this connection, whatever output signal we are expecting, that we will get across these two terminals, they are connected to the CRO. So during this experiment, on the signal generator, once if you set 20 millivolt, that 20 millivolt input signal you will not change throughout the experiment. What you have to change? Only the frequency, and that is starting from 50 Hz to 1.5 megahertz, and that is in steps. So change the frequency and note down the corresponding voltage appeared on the CRO screen. I hope all of you know the voltage measurement using CRO screen. How to measure voltage? Check the vertical height of the signal, that is in terms of centimeter. That height you multiply to the volts per division switch. What is the current position of the switch into the total height? If you multiply these two, you will get the resultant voltage, that may be in millivolt or may be in volt. So using CRO you find out the voltage. In this experiment we are not measuring frequency using CRO, that is not necessary. We are interested in input voltage and output voltage. So don't waste time to adjust the waveform on the CRO screen in terms of frequency. Adjust the waveform with the help of voltage only. Like that you will repeat the experiment. One more thing, just switch on. Switch on that also. This voltage is set for 9.1 volt, don't change. Right? Now you have to set the voltage on signal generator. Right? So carefully see here. 3 parameters are there. One is frequency, second is amplitude, and third is offset. For this year, you are not using offset value other than 0. So make sure that all the time this offset should be 0 millivolt. Before connecting the signal, adjust the amplitude 20 millivolt peak to peak. This you are not changing. Here frequency is just as an example, it is set for 50 kilohertz. Right? So here you can change. How to change? For example, blinker is on, means you can change the value of frequency now. Suppose if I make it 100, this is 100 and I want to make it hertz. Now see here, the frequency is 100 hertz. Like that, change the frequency from 50 hertz to 1.5 megahertz and corresponding readings you take on the CR. Right? Like that, you repeat the experiment, calculate the value of gain, go for dB. How to convert gain into dB? It is 20 log V output divided by V in. But V output divided by V in already you calculated in the next column. So just 20 log that value, gain will be converted into dB. Last time I told you the importance of dB. Only one thing I will tell you now. Our ear is responding to dB. That's why dB scale is very important. Other 2 points are there, we will not discuss that here. Right? What is the importance of dB? If anyone asks you, you just say our ear is responding not to the frequency, it is responding to the dB scale. So whatever sound level is there in terms of frequency, that sound level, if it is in dB, it will directly respond to our ear. That's why we have to convert the frequency or gain into dB. What is log F here? We want to plot the graph after completing the experiment. On x-axis you take log F and on y-axis you take gain. whenever you are plotting the response log f versus gain, whatever resultant line is there on the graph paper, that line is nothing but called as frequency response. We studied that the bandwidth of the amplifier should be more. Using that frequency response, we have to calculate the bandwidth. How we are calculating bandwidth? To the maximum value, we are multiplying by 0.707. The value will be reduced. With that value, we will draw one parallel line to the x-axis. That line will cross to that frequency response twice. First crossing is called as F1, second crossing point is called as F2. F2 minus F1, if you calculate, the value of bandwidth will be there. Here the bandwidth you have to convert from log f to f. If you take inverse of log f, you will get that log f will be converted into frequency. So that part you have to repeat once if you complete the reading and graph. Like that you can complete this experiment and you will observe that what is the change in the gain when circuit is working with feedback and without.